This Cold War submarine class was built in numbers unmatched by any other. Today, we find out what made the Los Angeles class the backbone of the US Navy submarine force. Between 1976 and 1996, the United States Navy commissioned 62 Los Angeles-class attack submarines, making it the largest class of nuclear-powered submarines ever built. But numbers alone don't tell the story. In this video, we'll explore the design innovations, technology, and strategy that gave the Los Angeles class significant advantage over its adversaries. During the height of the Cold War, beneath the world's oceans, competition between superpowers extended to submarine warfare. Control of the seas meant influence over global commerce, nuclear deterrence, and strategic positioning. This is the story of how American naval engineers created an advanced underwater platform that would define submarine warfare for decades. The late 1960s presented the United States Navy with a sobering reality. Soviet submarine technology was advancing at an alarming pace. The USSR had deployed nuclear-powered attack submarines that were faster, deeper diving, and increasingly sophisticated. Their Hotel-class ballistic missile submarines posed an existential threat to American cities, while their November and Victor-class attack boats threatened NATO shipping lanes and carrier battle groups. The US Navy's existing submarine fleet, built around the Sturgeon class, was becoming inadequate for the evolving threat environment. What was needed was a revolutionary approach, a submarine that could outrun, outhide, and outfight anything the Soviets could deploy. The answer would become the Los Angeles class, officially designated as the SSN 688 class. The program began in 1970 with a clear mandate: develop a fast, stealthy, multi-role attack submarine capable of maintaining American undersea dominance well into the 21st century. The specifications were ambitious: speeds exceeding 25 knots submerged, diving depths greater than previous classes, and noise levels so low they would be virtually undetectable to enemy passive sonar. The Los Angeles class represented a significant advancement in submarine design, beginning with its hull configuration. Naval architects at General Dynamics Electric Boats Division created a sleek, teardrop-shaped pressure hull, optimized for high-speed underwater movement. The teardrop hull form had been pioneered by the experimental USS Albacore in the 1950s, which demonstrated that this shape could dramatically reduce hydrodynamic drag compared to traditional cylindrical designs. The Los Angeles class refined this concept, incorporating lessons learned from earlier applications to create an optimal balance between speed, internal volume, and structural integrity. At 110 meters in length, with a beam of 10 meters, the submarines were significantly larger than their predecessors, but every dimension was purposefully designed. The hull incorporated carefully designed fairings that smoothed transitions between the main pressure hull and external appendages, such as the sail, rudder, and diving planes. These fairings eliminated sharp edges and discontinuities that would create turbulent flow and drag. Additional hull features included streamlined ballast tank configurations and flush-mounted sensors that maintained the smooth hydrodynamic profile. The hull's hydrodynamic efficiency was notable for more than just speed benefit. Unlike earlier submarines that sacrificed speed for other capabilities, the Los Angeles class could sustain speeds exceeding 25 knots while submerged, faster than most surface ships. The speed advantage was important for both offensive operations and evasion, allowing these submarines to rapidly reposition during combat or quickly close distance to targets. Superior hydrodynamics also contributed directly to stealth capabilities. The smooth water flow around the hull reduced flow noise, the sound created when water moves turbulently around submarine surfaces. By minimizing flow separation and turbulence, the teardrop shape and refined fairings significantly reduced this acoustic signature, making the submarine harder to detect even at higher speeds. The heart of this performance was the S6G pressurized water reactor, a masterpiece of nuclear engineering. Producing approximately 35,000 shaft horsepower, this reactor plant provided virtually unlimited underwater endurance. Unlike diesel-electric submarines that required regular surfacing or snorkeling, Los Angeles-class boats could remain submerged for months, limited only by crew endurance and food supplies. But speed means nothing without stealth. The Los Angeles class incorporated advanced noise reduction technologies of its era. The entire submarine was wrapped in anechoic tiles, specialized rubber coatings that absorbed enemy sonar pins rather than reflecting them back. These tiles, combined with sound-absorbing materials throughout the hull, substantially reduced the submarine's acoustic signature. Internal machinery was mounted on sophisticated isolation systems that prevented vibrations from transmitting through the hull into the surrounding water. The propulsion system employed a single 7-bladed screw designed for maximum efficiency and minimum noise generation. The 7-bladed configuration helped mitigate harmonics, regular, predictable sound frequencies that enemy sonar operators could identify and track. The large blade size reduced the propeller's rotational speed needed to generate thrust, which minimized cavitation. The formation of low-pressure bubbles around the blade tips that collapse violently and create distinctive acoustic signatures. The result was a submarine considerably quieter than previous American designs. At slow speeds, Los Angeles-class submarines are very difficult to pick up with passive sonar. Depth capability provided another important advantage. With a test depth exceeding 290 meters, nearly 60 meters deeper than the preceding Sturgeon class, Los Angeles submarines could exploit thermal layers and deep sound channels to enhance their stealth and survivability. This depth advantage also provided tactical flexibility, allowing these submarines to operate in areas where shallower diving opponents couldn't follow. Superior platforms require superior sensors, and the Los Angeles class delivered significant sonar capabilities that would influence underwater warfare for decades. The centerpiece was the AM-BQQ-5 sonar suite, featuring a large spherical bow array that represented an important shift in submarine sensor design. The spherical sonar array housed in the submarine's bow provided 360-degree acoustic coverage with enhanced sensitivity and range. The large aperture allowed for improved target resolution and the ability to track multiple contacts simultaneously. Later variants incorporated the more advanced BQQ-5D system, with improved digital processing and enhanced passive detection capabilities. The sonar suite was complemented by towed array systems, long hydrophone arrays deployed behind the submarine that could detect quiet targets at extended ranges. These towed arrays were particularly effective against Soviet submarines attempting to hide in thermal layers or operating at maximum stealth. Fire control systems integrated with the sonar suite, utilizing digital computers to calculate firing solutions with improved accuracy and speed. The Mark 117 fire control system could simultaneously track multiple targets while maintaining firing solutions on the highest priority target. Armament versatility distinguished the Los Angeles class from single-mission platforms. 4 533mm torpedo tubes could accommodate a variety of weapons, including the Mark 48 heavyweight torpedo, the advanced capability variant, a highly capable anti-submarine and anti-ship weapon. These torpedoes featured guidance systems featuring 2D phased array sonar operating across a wide range of frequencies. It also has high explosive warheads and the ability to engage targets at ranges exceeding 50 kilometers. Beginning with the USS Providence in 1985, later Los Angeles-class submarines incorporated vertical launch systems for Tomahawk cruise missiles. 12 vertical launch tubes provided land attack capabilities with precision-guided munitions that could strike targets over 1,600 kilometers inland. This capability converted attack submarines from pure anti-submarine and anti-shipping platforms into multi-mission strategic assets. Multi-mission capabilities transformed submarine warfare doctrine. Beyond traditional anti-submarine warfare, Los Angeles-class boats conducted intelligence-gathering missions, surveillance of foreign naval bases, special operations support, and later, precision land attacks with Tomahawk missiles. This versatility maximized the flexibility and value of each platform. Torpedo defense systems included acoustic decoy systems, acoustic countermeasures, and signals intelligence gathering equipment. These systems allowed Los Angeles-class submarines to evade enemy attacks while simultaneously collecting critical intelligence on Soviet naval operations and capabilities. Fast underwater movement allowed these submarines to rapidly transit between patrol areas or pursue fleeting targets. The speed advantage was particularly valuable during the Cold War when Soviet shipping and submarines might break out at any time from their home bases into the Atlantic or the Pacific. Agility underwater was also notable. Advanced control surfaces, as we discussed before, and powerful propulsion allowed the Los Angeles-class submarines to maneuver effectively, exploiting underwater terrain and thermal layers to maintain stealth while positioning for attacks. Crew efficiency and habitability improvements were often overlooked but critically important for mission success. Larger crew spaces, improved air purification systems, better food storage, and enhanced recreational facilities allowed crews to maintain peak performance during extended deployment. These quality-of-life improvements translated directly into operational effectiveness. During the Cold War's most intense period, the Los Angeles class faced formidable Soviet opponents, each representing different approaches to submarine warfare. Understanding these competitors reveals why American naval architects made specific design choices and how the Los Angeles class achieved key advantages. The Victor III class represented the Soviet Union's evolution of their successful Victor lineage. These submarines incorporated improved noise reduction technologies compared to earlier Victors, achieving significantly quieter operations than their predecessors. Armed with a mix of 533mm and 650mm torpedoes, and capable of respectable underwater speeds, Victor III submarines posed a genuine threat to NATO forces. However, compared to the Los Angeles class, their limitations became apparent. Victor III submarines, while quieter than older Soviet boats, remain significantly noisier than their American counterparts, making them detectable at longer ranges by the Los Angeles class's spherical sonar. On paper, the Victor III had one key advantage: 650mm torpedoes. These were designed to outrange and outpunch standard 533mm weapons, with some models capable of traveling over 100 kilometers and carrying massive warheads. In theory, this gave the Victor III the ability to strike from afar. But in practice, this range advantage was hard to realize. Launching such large torpedoes generated more noise, and the Victor III sonar and fire control systems lacked the sophistication needed to exploit their full range reliably. In contrast, the Los Angeles relied on the Mark 48 heavyweight torpedo, a smaller, wire-guided 533mm torpedo with smarter targeting, better mid-course correction, and faster engagement times. Perhaps most importantly, US submarines had the first shot advantage. They could detect and engage the Victor III before coming within effective fire-controlled range of its heavyweight torpedoes. And while the Soviet submarines had impressive destructive capability, their shallower maximum operating depth and less refined fire control systems left them disadvantaged compared to the more versatile and stealthier Los Angeles class. The Sierra class represented Soviet innovation in submarine construction, featuring titanium hulls that provided exceptional strength and corrosion resistance. This exotic material allowed for extreme diving depths that provided significant tactical advantages in many scenarios, with some estimates suggesting test depths exceeding 700 meters, far beyond the limits of conventional steel hulls. Sierra submarines were fast, durable, and capable of operations in areas where conventional steel submarines couldn't survive. Despite these impressive capabilities, the Sierra class suffered from fundamental limitations in terms of production scale. The complex metallurgy required for titanium construction and the more expensive raw material limited production numbers and dramatically increased maintenance requirements. Only 4 Sierra-class submarines were ever completed, compared to 62 Los Angeles-class boats. Some believe that the titanium hulls reduced noise levels radiated from the Sierra, but others claim that it amplified the noise. I don't have a strong view on that. The Akula class represented the Soviet Navy's most serious attempt to match the Los Angeles class. Introduced in the mid-1980s, the submarines incorporated advanced noise reduction technologies that brought their acoustic signatures to levels roughly comparable with the improved Los Angeles class variant. Akula submarines were fast, well-armed, and represented the pinnacle of Soviet submarine design. The improved Akula variant achieved impressive stealth levels that eliminated the decisive acoustic advantage long enjoyed by American submarines. For the first time since the early Cold War, Soviet submarines could potentially approach American levels of quietening, creating a more balanced underwater battle space. However, the Los Angeles class retained a crucial technological edge that proved decisive: sonar capability. While the Akula achieved comparable stealth, it couldn't match the sensor capability of its American counterpart. The Los Angeles class employed a large spherical bow sonar array that provided fundamental advantages in underwater detection and tracking. The spherical configuration offered wider acoustic coverage, better target resolution, and enhanced signal clarity across multiple frequency ranges. The large aperture size allowed for superior sensitivity and the ability to detect quiet targets at extended ranges. In contrast, the Akula class utilized a cylindrical bow sonar array, a configuration that imposed significant limitations on detection capabilities. The cylindrical design provided narrower acoustic coverage, requiring the submarine to maneuver more extensively to maintain contact with targets. Range limitations reduced the effectiveness of long-range target detection and tracking, forcing Akula submarines to operate closer to their targets to maintain situational awareness. The sonar superiority translated into decisive technical advantages. Los Angeles-class submarines could detect and track Akula-class boats at ranges where they themselves remain undetected. The sensor advantage allowed American submarines to maintain the initiative in underwater encounters, positioning themselves for optimal attack geometries while denying the same advantage to their opponent. Even as Soviet submarines closed the stealth gap, they couldn't overcome the fundamental sensor and sonar disadvantage that left them fighting blind against an opponent who could see them clearly. Okay, that might be an exaggeration, but you get my point. The combination of comparable stealth levels but superior sensor capabilities means that while Soviet submarines had achieved rough acoustic parity, they still operated at a decisive disadvantage in underwater combat scenarios. The Los Angeles class had evolved from a platform with stealth superiority to one with decisive sensor superiority, maintaining American underwater edge. The integration of multiple advanced technologies into a single, coherent, effective platform solidified the Los Angeles class's role as the Cold War's submarine masterpiece. Although the Akula class is also an engineering marvel in its own right. The impact of the Los Angeles class on naval warfare extended far beyond individual submarine capabilities. These platforms fundamentally shifted the balance of power in Cold War undersea operations, establishing American dominance in the world's oceans and constraining Soviet naval strategy. During the 1980s, Los Angeles-class submarines regularly operated in Soviet home waters, shadowing ballistic missile submarines and monitoring naval activities with a degree of impunity. This intelligence-gathering capability provided American strategic planners with unprecedented insights into Soviet naval capabilities and operational patterns. The psychological impact on Soviet naval commanders was not to be discounted. The knowledge that American submarines could operate undetected in their most secure areas undermined confidence. The Los Angeles class influenced submarine design philosophy worldwide. Elder naval powers studied American acoustic reduction techniques, sonar configurations, and operational concepts. The emphasis on multi-mission capabilities became a standard requirement for modern submarine designs, while the integration of land attack missiles transformed submarines from purely naval platforms into comprehensive tactical weapon systems. The longevity of the Los Angeles class design speaks to its fundamental soundness. Despite being designed in the 1970s, many of these submarines remained operationally relevant well into the 21st century through modernization programs. Better sonar systems, updated weapons, improved combat systems, and enhanced communication suites kept these platforms competitive against much newer opponents. Modern submarine designers still grapple with the same fundamental challenges addressed by Los Angeles-class engineers, balancing stealth with speed, power requirements with sensor capability, optimizing hull designs for multiple mission profiles, and integrating more weapons and longer-range weapons and torpedo countermeasure systems into coherent, effective platforms. The future of underwater dominance will be shaped by the same principles that's made the Los Angeles class successful. Larger sonars with more comprehensive acoustic coverage, perhaps stealthier counters against active sonars like angular shapes, and the ability to integrate new technology like the VLS when it was first invented, and remaining relevant across decades of changing standards and requirements. In that sense, many advanced submarines launched nowadays carries the DNA of the Los Angeles class, a Cold War masterpiece.